Okay, welcome back. We are going today to be graphing this function right here. So this is the one I put up in class, so hopefully you've had a good chance to kind of go through it. So let's go through it. So the first thing we have is we have our position function here, and we're going to go find our important stuff. So I'm going to go find the x-intercepts. In order to find the x-intercepts, we set f of x equal to 0. Next, I'm going to do some factoring here. So I am going to pull out an x to the 4/3 out of both terms. And then we set each factor equal to 0. And solve. So obviously the left-hand side is x equals 0. Right-hand side, let's see what we get here. So I'm going to cube both sides, and I get x equals, what is that, 125 over 8. So I have two x-intercepts. My x-intercepts are 0 and 125 over 8, which is about 15.6. Okay, so that's f of x. Let's take care of f prime of x. So when we take the derivative, we end up with this. And we're going to do the same thing. So I'm going to set it equal to 0 and see what I get. Now I'm going to pull out, I'm going to actually multiply everything by 3 right off the bat. So I get this. Then I'm going to pull out an x to the 1/3. Whoops. That's fine. That's fine. And I'm actually going to, not that it matters, but I'm going to divide both sides by 10 just to make things a little easier. I actually meant to do that originally, and I didn't. It really doesn't matter. I think you guys would agree, but whatever. Okay, so setting each of those factors equal to 0, I get x to the 1/3 equals 0, and this stuff equals 0. So I get x equals 0, x equals 8. Okay, so these are our critical values, and they occur at the points, I'm just going to list them. This is the point 0, 0, and this is the point 8, -16. So let's make a sign chart for that. So we have 0 and 8, -16. So when I go and make my sign chart for the derivative, I get plus, minus, plus. Feel free to check me, but I don't want to spend the time going over it on this video. So let's move on to second derivative. Again, I'm trying to keep the video short, so if it feels like I'm kind of rushing through things, I'm trying not to make a 20-minute video here. So taking my second derivative, I get this. So let's see, set it equal to 0. Now actually in this case what I'm going to do is I'm going to clean it up. So what I end up doing is I got a common denominator and things like that. So when I cleaned it up, I got this. This was basically, I do want to get a common denominator because in order to find my critical values and things like that, I need it to be one fraction. So this is my f prime function. And I think you guys would agree. I then set it equal, oops, sorry, that's my f double prime function. So then we set it equal to 0, and I look at both the numerator and the denominator. So the denominator, well, okay, let's start with the numerator, I guess. So the numerator equals 0 when we get this. So when x equals 1. And then the denominator, I think you guys would agree, is x equals 0 when, or sorry, the denominator equals 0 when x equals 0. Okay, so making a sign chart for our second derivative. Oh, by the way, let's get points here. I know, kind of spazzing out here. Whoops, why is this not writing? So I have the point 0, 0 that we already knew about, and I also have the point 1. Having a lot of problems here. Pen is not happy. So 1, negative 1. So making my sign chart for my second derivative, and I'm gonna kind of make a summary of the stuff just because this is a bit messy and hard to follow on this small screen. So I have my inflection points here and here. So, and when I get it, I get this. Okay, so let's see what we can do. So again, I'm gonna kind of summarize what we got here. I'm gonna kind of put it all together here. So for the first derivative, well, let's see. We got x-intercepts at 0 and 125 over 8. So x-intercepts at 0 and 125 over 8. We have, for our first derivative, I'm just going to kind of copy the chart that I have here. So for our first derivative, we have this. And for our second derivative, we have this. And finally, let's just kind of list our points that we're going to be plotting when we get to it. So for our first derivative, our critical points were 0, 0, and 8, negative 16. So critical numbers 0, 0, and what did I say? I think 8, negative 16. 8, negative 16. And then for our flexion points, we had 0, 0, and 1, negative 1. Okay, so we have all the information right here. I'm just going to put a line here. We have all the information that we need in order to graph. So let's go through and graph it. Okay, so it looks like the y values are going to go, what I said 125 divided by 8 is about almost 16-ish. And so it looks like it's going to go from about like negative 16 to 16. So how about the y values go by tens? And then the x values look like, whoops, you know that 125 over 8 was actually an x value. So the y values, still good numbers for the y values, but that 125 over 8 is an x value, so I do need to plan on that too. So I'm going to say, how about 5, 10, 15, 20? So these will go by 5s. Hopefully that wasn't confusing to you guys. Okay, so let's put this all together. For the sign chart, I didn't make my minimums and maxes, so it's probably a good time to go and do that. So for the first derivative, I've got a maximum here and a minimum here. For the second derivative, it is concave down here, concave down here, concave up there. Okay, so putting this together, let's go plot some points. So x-intercepts, we had one at 0, and 125 over 8, which I said was about 16. So I'm going to say here. Okay, then let's get our critical values. So 0, 0 is already plotted, and 8, negative 16 is, so I was going by 10, so 8, negative 16 is maybe here. Okay, I think, and we need the inflection point. So 0, 0, and 1, negative 1, which we'll call right here. Okay, so let's see what we got. So looking at our first derivative, I see that it is increasing all the way to 0, and it is concave down. So increasing concave down. After 0, it is decreasing. It's decreasing all the way to 8, right? And it is still concave down to 1. Okay, so it is decreasing and concave down to 1. So concave down to 1. After 1, it is concave up. And that's going to go all the way to 8. So it's going to do something like that. Let's make that a little better. So there we go. So decreasing, concave up. Looks good. Now from 8 on, it's going to be increasing, and again, it's going to remain concave up. So looks like that. And that is our graph. Enjoy.